So hey guys, we are here to present about our research which was focused on affordable housing. It's me, Bhumit and Sheila that will be presenting this research. Next slide. So we'll start off with looking at affordable housing on a macro level. Then we'll delve deeper into the micro level research about affordable housing. Following that, we'll kind of shift our focus to modular construction and the barriers, the challenges, and the solutions to those barriers. And we'll end our presentation with the perspective from people who have worked in the industry and who know about modular construction. So Sheila will start off the presentation now.
Mm-hmm. So for the macro level, we first wanted to look at affordable housing from a global perspective, what it meant to other countries and what other countries were doing. Then we compared different cities, specifically Hong Kong and Singapore. And then we kind of came back home and looked at New York City and San Francisco in detail, and even further delve into New York City and just the different incentives that it has to kind of spur affordable housing. Next slide, please. So before we begin, we first like to go through some key terms. So first, what does affordable housing mean? And kind of when we looked at different countries and different places, they had different meanings for affordable housing. But in the US, we define housing as affordable if the family spends no more than 30% of their income to live there. And that's usually their after-tax income. And another important thing is area median income. So area median income, it just means that half of a geographic area's household income is above that midpoint, while the other half is below that amount. So for example, the area median income of the Washington, D.C. metro area is about $117,000. And but it's AMI, 80% of that would be $77,600. And that this metric is really important to figure out who qualifies for affordable housing, because some cities can say, okay, if you make 60% of AMI, you qualify. If you make 40% of AMI, you qualify. Also, area median income is a very tricky metric to use. For example, in New York City, for the area that they actually take into account is Westchester County with New York City. And Westchester County is a more affluent area. So that can kind of skew the numbers a little bit. Next slide, please. So the next thing that we want to talk about is the affordability gap. And there's a housing gap projected in 2025 of 440 million households that won't be able to have affordable housing. And in monetary terms, that's $650 billion. And we would need about $16 trillion estimated investment to make housing more affordable. Next slide, please. So the least affordable housing markets, this is a study done by the International Business Times, and they took the housing price to income ratio to do this measure. And as we can see, the least affordable housing market is Hong Kong by far. And another thing that's really interesting about this slide is that the two countries that are most unaffordable are Australia and the US. And more specifically, if you look at this in the US, the most cities that are unaffordable are all in California, with the exception of Honolulu. Next slide, please. And so we thought this slide was interesting if you look at housing affordability over time. So as you can see on this slide, this is from 2004 to 2016, and housing affordability, so the price of housing hasn't changed as much, with the exception for Hong Kong, where the housing inaffordability has grown exponentially over time. And as you can see, the other housing markets, they went up before the crash, and then after the crash, they come down, and then now it's kind of slowly coming back up as the market recovers. Next slide, please. So we saw that Hong Kong is highly unaffordable, and we kind of looked at its neighbor, Singapore, who is a very similar city, and they're totally, completely different in terms of housing and affordability. So we wanted to look into this issue a little bit deeper. What policies did these governments have that kind of incentivize affordable housing or de-incentivize affordable housing? So this is a snapshot of Singapore, whose home ownership is very high at 90.5% of the population owning homes. The median property value is about 874,000, and its median household income is about 81,000. This is US dollars. And compare that with Hong Kong, where home ownership is about 51%, about half, and the median property value is 1.2 million, and the median household income is 42,000. So that's very, very disproportionate. Next slide. So if we look at home ownership in Hong Kong versus Singapore a little bit more deeply, in Hong Kong, the market is mostly private. At about 75% is privately owned, where the rest is public housing. Whereas Singapore is pretty much the opposite, where 19.9 is public housing, while the rest is privately owned housing. Next slide. And these two countries are quite similar. So as you can see, that they're both located at the heart of the Asian continent, similar colonial history. Population growth is similar, with Hong Kong being at 1, Singapore being slightly higher at 1.2%. Salaries are fairly equal. The unemployment rate is low. There's high foreign investments with tax-friendly policies. But however, as you can see, the housing situation is very, very different between both countries. Next slide, please. So in Singapore, they have a housing development board that handles their housing issues, and 5% of land is classified as protected. They have a sovereign-controlled social security, and that's called the Central Provident Fund. And Singaporeans are given a $20,000 subsidy for their first-time home purchase. Compare that with Hong Kong, where 40% of land is classified as protected, and the average subsidy is only 1,700 Hong Kong dollars, which is less than 1/5 of the average income, so very low subsidy. And if you just look at the different housing breakdowns, Singapore is just mostly public, then private, whereas in Hong Kong, you have the private housing market, you have the public rental market, plus you have your government subsidized flats. Next slide, please. All right, so coming back home, so this is San Francisco. And as you can see, as compared to the United States, which has about a $60,000 median household income, 63.9% home ownership, and a median property value of about $217,000. contrast that with San Francisco, which has double the median household income at 110%, which most people think that's great. That's double, the national average. But if you look at the property value, it's super high. It's $1.1 million median property value. And the home ownership is much less at 36.5%. Next slide. And we wanted to look at the cost of living, because sometimes the income doesn't tell you the whole story. So for example, in San Francisco, 2 adults, both working with 2 children, they would need about $94,000 per year just to afford basic living expenses, as medical, food, housing, transportation. And housing is very high. It's $31,000 a year, which is about $2,600 a month. Next slide, please. And so what kind of salaries and professions can afford to have you live in San Francisco? Well, it's really not that many, unless you're, in the STEM fields or the legal fields. So as you can see here, the top are, healthcare, legal, the sciences, engineering, computer science, business, and management. If you're so-called, a blue-collar worker, more in the construction trades, sales, transportation, it's very, very tough to, even on a dual income, to afford living in San Francisco. Next slide. So next we come over to New York. Again, compared to the United States, similar median household income. Property values are higher at $600,000, not as bad as San Francisco, and home ownership is 32.7%. Next slide. And so looking again at living wage calculator, slightly better than San Francisco. A family of 4 with 2 adults need about $90,000 a year to afford basic living expenses. Next slide. And again, as you can see, what professions will allow you to live somewhat comfortably in New York City is, the healthcare fields, legal fields, again, architecture, engineering, computer science, business, management, and everyone else is not as much. It would be a struggle. Next slide. And another thing that we wanted to look at is what actually goes into building a property and property development. So usually when developers are kind of doing their models, they look at the cost of land acquisition costs. They have design and construction costs. They also have, the financing fees. They have their reserves, and finally the developer fees. And that goes into the total cost of development. And so depending on the area, the developer has to kind of charge the renter enough to cover all these costs and fees and still yield a healthy return for their investors. So right now that would lead to more of a luxury than more affordable housing. So it's more difficult for them to develop affordable housing just because of it's harder for them to recuperate these costs. And next slide. And then Bhumit will go through the current affordable housing crisis in New York City.
Thank you, Sheila. So let's discuss, let's go deeper into the New York City market. So one of the biggest reasons why there's an increase in the affordable housing demand is that the median gross rent has been increasing since the year 2005 to 2012, but the median renter income is not exactly increasing. It is almost stagnant. There's an increase of 11% in the gross rent, but the income has almost been the same. Along with the rent increasing and the income remaining the same, the affordability of the household will decrease. So that's the reason why there's an increasing demand in the affordable housing market. So along with the rent increasing, there is also utility costs that has increased in the past. From the year 2000, there has almost been a 20% increase in that. Next slide. So now, the graph on the left hand side signifies the supply demand gap for extremely and very low income renter households, and the yellow bar suggests that around 420,000 households are affordable to these groups of people. Um, and there's a demand of almost 980,000 households, which is almost twice the demand. And the graph on the right hand side shows the increasing amount of rent burden households from the year 2000 to 2012. So if the household pays more than 30% of their income in rent, it is considered to be rent burden. And if the household is paying more than 50% in rent, more than 50% of income in rent, it is considered to be severely rent burden. So since 2000, since the year 2000, the increase in rent burdened household has been 11% um, uh, till the year 2012. So moving forward, the graph on the left-hand side shows the increasing population that lives in the New York City shelter. So it has increased from almost 20,000 to almost 50,000 in the last, let's say 25 years. Um, so, so with the increasing number of people living in the shelter, it is difficult to accommodate new entrants, and we have to consider increasing the capacity of the shelters, and which can be costly and challenging. The graph on the right shows the increasing population in the city of New York. So right now it's around 8.2 million, and it is projected that it will go on to almost 9 million in the year 2040. So, so to overcome all these challenges that we have been seeing in these past few slides, Mayor de Blasio laid out a comprehensive plan to build and preserve 200,000 affordable housing units in the next 10 years to support New Yorkers with a range of income from the very lowest to the middle income category. So this plan lays out targets for new construction and preservation. So almost there are 200,000 houses, out of it 60% will be for preservation and 40% will be for new construction. And it will be among 5 income categories. So 8% of these housing developments would be for extremely low income, which has an AMI of less than 30%. 12% of these households, of these developments would be for very low income, who has an AMI of less than 50%, from 30 to 50%, sorry. And 58% of these developments would be for low income households, which is from 50 to 80% of AMI. And 11% would be for middle income and moderate income, with an AMI of 80 to 120% and 120 to 165% respectively. So now let's discuss the challenges which are involved in the development of affordable housing in cities as dense as New York. So there can be many challenges that need to be overcome. And to provide affordable housing, we have taken a value chain approach to determine the challenges. So when we look at the supply side value chain, the first step that comes is the land acquisition and securing the title. So this is one of the most important complicated piece of the puzzle, because when it comes to land acquisition, the process entails confirmation of ownership. A survey of land is also required. We have to determine the market value of the land. And also we have to go forward with procurement of land. If it's government land, there would be a proper process which needs to be gone through. And if it's a private land, negotiation of price will take place. So after we acquire the land, we have to look at the land use and the zoning regulations of this land. So, with cities as big as New York, urban land cover is growing more quickly than urban population. So, proper zoning of affordable housing and multi-family housing is very important to provide developments for the low-income households. So, the next step is now funding this affordable housing project. So that they require adequate financing structures and funding. So it is proper funding is also critical to these affordable housing units, and the developers needs proper financial structure and instruments which help them build these houses. Sorry. So now we'll discuss the next step, which is the housing design and development cost. So uh, as these affordable housing are made, they are either government made or privately made. So either of this, however they are made, there are design and development costs, which affect the total cost of developing this affordable housing. So innovations in design and construction and productivity can help in alleviating some of these challenges. And our further part of research, which is modular construction, focuses on reducing the design and development costs. Now we'll talk about the demand side value chain. So so the main focus when it comes to the demand side value chain is that the household should be able to secure loans for either renting or purchasing a housing unit. So the first step when it comes to the demand side value chain is that we have to determine the eligibility of of the family. So we have to we have to see that which part of the which category of income they lie in, and according to the AMI of the area. Um, and so after that, we'll have to evaluate the purchasing model. So if either the household would like to own the property or rent the property, and the final step of that would be credit financing. So proper so financial institutions need to be established. Financial instruments needs to be established in so that these households can take a loan and finance their so that they can finance while purchasing or renting a house. After taking the steps, the household would be able to purchase the house. So next step. So this is so we discussed the macro level of affordable housing in New York. So now we'll talk about micro level. We'll go in a more micro level where we talk about individual to individual. So the first thing we'll talk about is relating housing to Maslow's hierarchy of needs, and then we'll talk about effects of housing on a person's well-being. So after so after actually thinking about it, it's not only that these people who are to be these households that are to be provided affordable housing, we also need to see that they're satisfied enough and motivated enough to do well in life after they get the housing. So Abraham Maslow actually proposed a structure, a pyramid of needs, which states that a person is motivated after he fulfills the first need, and he'll go on to the next need. So the first need is the psychological needs when it comes to a person, which is providing basic food, water, and shelter. So when it comes to affordable housing, the psychological need would be providing a shelter, and such that they're provided utilities as well, like electricity, gas, air conditioning, heating, etc. After providing the psychological needs, we need to focus on providing the safety needs. So the housing unit should be in a safe neighborhood, and the people who are living in that unit should feel safe. The third The third stage is the love and belonging. This stage states that uh, the next need of the person is to be feel loved by others. So when it comes to housing, the house should have common areas like dining room or living room, so that the family can interact and build better bonds with each other. The next need would be the need of esteem. So then it basically means that the person would want self-respect with the work that he's doing, with the life he's leading. So when it comes to this need, it is important that we provide management to these household units, because if the person is living in a well-managed, affordable unit, um, he would have more self-respect than rather than just living in a old house which is torn down since a long time. So after providing these needs, these people would actually feel self-actualized, and they would also like they are the best version of themselves. So this is a very interesting thing. It's not about just providing a shelter for these people to live, but it is also about providing the necessary characteristics in which they can become better people. Now Sheila will take over importance of housing stability on a person's well-being.
Yes, so just going off of what Bhumit had said, um, so housing stability is really uh, the basis for a lot of things, and that includes health and wellness, economic advancement, youth development, and community engagement. And usually without, so for example, if you don't have housing, you're not really thinking about how can I advance at work, or how can I get involved in my community. So having a stable housing situation is very important on a person's well-being. Next slide, please. So first, next, let's focus on housing stability and health. So without housing, so there are different types of housing instability. So first of all, there's homelessness. And then there's you have high housing costs relative to your income. Another thing is overcrowding in your home. Next is poor housing quality. And another one is you just move multiple times. And these are, associated with many health risks. So that includes for children, that is just poor health.
Sorry.
Sorry, yeah, right. So that's poor health, especially if you're living in poor housing quality, with asthma, low weight, developmental delays, um, and increased lifetime risk of depression. And some of the health risks for adults are reduced access to care, postponing needed health care just because you have very high housing costs and that needs to be paid first. That kind of leads to more mental distress, difficulty sleeping, and much more uh, uh, incidents of depression. And so in terms of increased anxiety, so adults who felt worried or stressed about their ability to pay their rent or mortgage were 3 times more likely to report mental distress, and were almost 50% more likely to have trouble sleeping. So all of these, as you can see, have long-term physical and mental health. Next slide, please. So housing instability has a really big impact on education. So, let's say you have an unstable housing situation or you're homeless and you're a child. So that leads to more stress, difficulty learning, which can also, things like multiple moves can disrupt your school attendance, and that all kind of leads to poor poor school performance. And they found that for low income students, even changing homes one time in elementary school can have a negative effect on school performance. And that can kind of cause a domino effect and can contribute to a long-lasting achievement gap. Next slide, please. And another thing to consider when you're looking into affordable housing is transportation, because some affordable housing units are very, very far from where the jobs are, basically. So for example, the average worker can only reach about 7% of the jobs in their region with a one-way 45-minute transit commute. And only 25% of low and middle skilled jobs are within a 90-minute one-way transit commute of where low and middle income families live. So that's a lot of time spent on getting to and from work. And transit access can be a particularly critical issue for low income older adults who can no longer drive and rely on public transportation to reach necessary services like medical or dental offices. Next slide. And next, we're going to delve into different construction technologies, such as modular construction, that can decrease the price of affordable housing, potentially. So Smith, you can take it away.
Yeah, so now we'll delve deeper into a sustainable solution, to deliver this deliver affordable homes in a faster way. And one such solution that we focused on is modular construction. So we'll start off with an overview about modular construction. Then we'll address the challenges, the labor and the logistics challenge that modular construction brings, and the financing challenges when it comes to modular construction. Next slide. So these are the phases of modular construction. First is the design phase. It's very necessary to create an accurate description of building with detailed plans and specifications. This is one of the most important phases when it comes to modular construction, because once the design is locked and the modules are being manufactured, there can be no room for any change in design. The second phase is the manufacturing and assembly. So once, like I said before, once we've decided on the designs, it's necessary to get into the production phase and start the fabrication and assembling of modules in a warehouse or a casting yard. Following that, it's essential to transport these modules to the site where the construction is happening. And once they are transported, the last and final phase is the installation or the assembling of those modules on the sites. Modules are erected and the structure is kind of assembled, we can say, or constructed. Moving on, next slide, please. So why should we opt for modular construction? Apart from the fact that it's being done in a more controlled environment, there are substantial monetary benefits to the developers. So reading a report on modular construction, 24% of the clients feel that there's a 5% reduction in cost. 19% of the client feel that there's a reduction in the range of 5 to 10% of the cost. 17% of the clients feel that there's 10 to 20% reduction in the cost. And one major takeaway when it comes to opting for modular construction is the increase in productivity. And the developers who've opted for 82% of the developers who opted for modular construction have obtained a substantial increase in the productivity. Uh, Next slide, please. So, what's the difference when it comes when you're comparing a conventional construction method versus a modular way of constructing? So, as we can see, the modules are constructed inside a controlled environment on the in a warehouse. Uh, the main the main factor which saves time when we choose modular construction is that there's no site restoration happening, because all the modules are kind of fabricated inside a factory and then they're assembled on site. So there's not much room for site restoration, and the site can be ready to use. The building can be ready to use by the uh, tenants or the people who are going to live in that building uh, once all the modules are assembled and the vertical structure is constructed. So this particular factor, this the absence of site restoration constitutes to a 30 to 50% saving when it comes to the schedule of a project. Next slide, please. So these are the three main challenges when it comes to modular construction. The first main challenge is the design phase. As I said before, is the most important phase. Once the design is locked, there's no room for any change in design. As we can see, if the design is not perfect, there can be an issue later because modules have already started to be manufactured, and there can be substantial damage when it comes to cost, when it comes to schedule, if there's even a slight change in design uh, in the later phase of a construction project. The second main challenge is a logistics challenge. As you can see, all of us are in the city of New York, and our research is based in New York, and it's really difficult to transport these modules from a factory to a site. This is one of the main challenge when it comes to modular construction. If a developer has opted for 3D volumetric modular construction system, a slight damage during transportation of these modules can lead to delay uh, and a change in cost or the budget of the project. The third challenge that we've discussed is the financing challenge. As we can clearly see, there's a lot of time and effort that is spent during the initial design phase or the pre-planning phase of a project. So compared to traditional or conventional construction, a large amount of investment is required upfront when it comes to modular construction. So these are the challenges which we've looked into after talking to various real estate developers and contractors who have experience when it comes to modular construction. Next slide, please. So this is from the McKinsey report. As you can clearly see, uh, as we increase the complexity of a single unit or single structure, there is an increase in the complexity or the efficiency of, of the structure as a whole. So when we start off initially with individual units which are made of concrete, steel, or wood, uh, we uh, we we end up building a complete structure without any MEP installations or furnishing. As we increase the complexity, or as we increase or include some features, some essential features like installation of uh, pipelines or windows, uh, the construction can turn like the end of the construction phase, we can get a fully serviced and a furnished house. So it all depends, it's all subjective, it's different for different projects. It depends on the developer and his needs. It depends on the client we are building the structure for, and it depends on the financing um, that a project gets when it comes to modular construction. The more intricate the design in the initial phase, the less obstacle that the less obstacles a contractor will face when it comes to assembling these modules on site. Next slide, please. So as I talked before, there are two types of modular construction systems. One is the 2D panelized system, and the other one is a 3D volumetric system. So as you can clearly see, as the complexity of a project increases, the need to choose or opt for a 3D volumetric modular system increases. So as we start off looking at this picture that we have in front of us, if we opt for building a single family housing, we can complete the project easily using 2D panelized structures. But as we keep on increasing the scope and the complexity of a project, the need to opt for the 3D volumetric system increases. That's particularly because the 3D volumetric system requires standardization and repeatability. Um, Whereas when you build a single family housing, the need to manufacture 3D modules reduces, because these 2D panels can easily be assembled on site for a single family house. Next slide, please. So this is a particular model of a permitting process in San Francisco. In San Francisco, there's this unique way of obtaining permits when it comes to modular construction. Modular construction is traditionally called factory-built housing, and there's a state agency which looks after the permitting of the modules built inside a factory. Once those modules are approved by the people that represent this entity, uh, these modules are then again transported on site, and then they're again checked and inspected by the local municipal body of San Francisco. So such a system can lead to delay in a project, because these modules are checked two times by different entities, by different agencies, by different sets of people, and all of them, they kind of have different codes and different standards when it comes to quality. So a contractor usually ends up going to and fro from a local municipal agency to a state agency which looks after all the factory built housing uh, in the state of California. And also it's necessary that the architecture and the contractor are on the same page. And it's essential that the architect which has initially designed the modules, he's available when those modules are assembled on site and when they are being inspected by the local municipal agencies. Next slide, please. So now Bhumit will explain more on the labor and the logistics challenge in modular construction.
Thank you. So now before just getting into the labor and logistics parts of modular construction, I would like to just talk about this particular graph that we came across. So this is a graph in which shows the normalized rate of construction as time passes in both USA and UK. So between 1940s and 1950s, US saw an increase in the production of houses using modular construction because of the post-war housing boom, because of which there was an increase in the demand of housing in USA. But the housing demand reduced in 1950s, after which modular construction was not as prevalent. Similarly, in UK, prefabrication and modular construction saw an increase in demand because they wanted to replace the war damage, and also the it was financially cheaper. But it also saw an end after 1968 when the Ronan Point building caught fire, and it was associated with quality safety concerns as to if prefabricated buildings are safer or not. So after that, modular industry has been really dormant. But since the year 2000, there has been a labor crunch worldwide. When it comes to the construction industry, there have been productivity issues because of which modular construction is increasing. When it comes to giving supply to the increasing demand of housing. Um, so because of this labor crunch, there has been an increase in the trend of using modular construction, and I think so this time it will be more sustainable than the previous periods in 1940s and 1960s, just because of one of the biggest reason that now we are living in the 21st century, and it is a more digitized age, and we are much more technologically advanced when it comes to implementing technology in construction. So this time modular construction can last for a longer time than it lasted previously in 1940s and 1960s. So one of the main things that modular construction helps in is that most of the construction of the building is taken off site rather than doing it on site. One of the biggest reasons why off-site constructions should be implemented, because according to a research done by Wilmot Modular, which is a company, is that there's a shortage of skilled labor on job site, and so we can take most of the work off-site and do it take most of the work off-site and do it uh, off-site, so that the shortage shortage of labor on-site is less prevalent, and the workers that are working off-site would be working on individual modules, so that the shortage of labor would not be as visible. So there's an increased pressure on project cost, and making a modular building would reduce the project cost and project schedules. Since there's an improvement in the technology implemented with the implementation of ERP systems, with the implementation of a proper supply chain, um, we could also improve the production of modular construction as we go in the future. So every project is different, and so which needs to be accounted for, and every different project should have a different logistics and transportation strategy according to where the project is made and which company is doing the project. So these are a few best practices which should be implemented while making a modular constructed building. So the first best practice according to us would be to have a separate entity for logistics and transportation, where there's a proper team, where there's a team leader who's working on how they'll supply the logistics from offsite to onsite and how it will be transported. So, and the next best practice would be the total delivery cost management. So throughout the project, there would be multiple deliveries, and cost management can be done using a robust ERP system. So you can also always implement total delivery cost management systems. The next thing which should be done is identifying the route which should be taken by the truck driver, because the trucks which would be transporting these modules would be very huge, and most of the roads would not be able to would not be accessible to these trucks. So route identification is one of the most important things. Then comes variability management. So when it comes to transporting these goods, there are some unexpected um, occurrences that can happen, and proper risk management should be done when it comes to these unexpected incidents that might happen. So variability management is also very important. Financial supply chain management should also be done so that you are optimizing your working capital. And last but not the least, a proper ERP system should be implemented so that there is process automation and you're using as less time as possible to build a particular module. Now Sheila will take over to on-site installation.
Yes, thank you, Bhumit. So just focusing a little bit more on site. So on site, once the modules, sorry, get there, usually the on-site installation includes mat line connections for MEP. You have your exterior connections, exterior finishes, and interior finishes. And actually, the crane is usually the most expensive part of the installation process. Next slide, please. And so looking at the financial considerations, usually it's production volume, so how much supply and demand you will have, on-site versus off-site construction, and also the lending practices. Next slide. So in terms of production volume, in order to diversify against the cyclical nature of the building industry, manufacturers, they need a wide range of product pipelines, such as student housing, hospitality, multifamily rental, family owner, assisted living, and more, just so they can, because they have a lot of fixed costs in the factory, just paying rent and their workers. So keeping a steady volume of work is very, very crucial for a modular manufacturer. Next slide. And then the next thing to figure out is, are you going to do the work on-site or off-site? So in modular construction, really the best that you're looking at is about 70% of work can be taken off-site, but 30% still needs to be done on-site. And usually that includes, if you look at the slide on the right, that's usually the foundation, just general services of engineering. You have your exterior finishes and your interior finishes. Next slide. But there are definitely big saving opportunities, up to 20% savings. So if you look at modular construction, really the savings that you'll see is labor and materials. But however, you do run the risk of increasing the cost of the project about 10% if labor savings are outweighed by logistics and material costs. Next slide. So some of the financing challenges of modular construction. So first is completion guarantees. So usually there's some kind of guarantee that the lender would want, and that's very, very high cost. Another one is a low supply of manufacturers, and so low supply tends to lead to higher costs. And also, finally, there's a high initial cost of capital, just because the modular manufacturer needs a high upfront cost to build a factory, get the materials, and so because of that, they require a higher deposit. So sometimes about up to 40% of the cost of the modules just to begin manufacturing. And so sometimes the lenders, they're not used to giving out such a huge chunk of money at one time. So that's another tricky financing component of modular construction. Next slide. And the factors that determine the attractiveness of a market for modular construction. So first is demand. So definitely continuous volumes of demand. Second is the labor dynamics. In New York, is very highly union labor. And so if the unions do not like modular construction, then it'll be very, very difficult for the general contractor to get modules on. And the next thing is just local site constraints. For example, in New York, not all the land is a perfect square that can fit perfectly inside the modules. You can get very, very tricky land shapes, or just for example, like how low street volumes might be very high, narrow streets, things like that. So that might inhibit your modular project. Next thing is supply chain and logistics. So where you are can determine, how quickly you get the modules, how fast you can get them, and what cost you can get them at. Another thing is quality perception. Some people might think, modular is not as high quality as conventional methods. The next thing is access to the proper materials, and finally, regulation. But really the two key things are labor dynamics. Can you get the right labor? Second is demand volumes. Next slide. And another thing that we looked at was industry perspectives on modular construction. So we talked to a bunch of industry professionals and to get their opinion on the current state of modular construction. And we talked to a couple of manufacturers such as Full Stack, Modular, and Skender Construction. We got an architect's perspective from Garrison Architects. And finally, a legal perspective by Professor Bob Rubin. And next slide, please. And Bhumit will start us off on a manufacturer's perspective of, and we're talking about full stack modular.
Thank you, Sheila. So this is the first company that we interviewed, and luckily this was before the COVID outbreak. So we actually went to the manufacturing unit. We did a factory tour, which was quite interesting. So introducing the company, Full Stack Modular was founded by Roger Krulak after in 2016, which focuses on manufacturing of modular construction and transporting it to the construction site. So the firm specializes in modular manufacturing and construction by optimizing production and assembly. So in the future project pipeline, 250,000 square foot is the first one is a 250,000 of square foot of affordable housing for New York City in collaboration with the New York City Housing Authority. Out of this, 80,000 square foot is in Far Rockaway and 160,000 square foot is in Fulton Street. They are also focusing on student housing and hotels in their future projects, so they are making their design library for that. So we discussed a few challenges, and these were the ones which resonated with us and which were actually talked about by the people at Full Stack. So we had a conversation with Vincent Nasri, who is the modular optimization engineer, and Daniel Timianko, who is the director of strategic initiatives. So one of the first challenge that we discussed about was the zoning issues. So mostly in New York, whatever construction is done is vertical construction, and So there's no natural development so there's no open areas in New York, so that natural development of construction site can occur in terms of horizontal construction. So there's mostly vertical construction, and since there's only vertical construction, the land costs are going up, which offers lower margins to contractors and designers who are working on the projects. So their aim in doing modular construction is that they can achieve efficiencies in material, procurement, and labor, so that they can, increase the margin of profit when it comes to, as a whole project. The next issue that we talked about was the union labor. So as we all know, union labor can be more expensive and they are mandatory when it comes to building affordable housing. But when it comes to full stack, they love their union because they achieve what they call labor flexibility. But so, for example, if they have a union for plumbers, union labor who specialize in plumbing, they are also accepting to do work which is electrical and vice versa as well. So they achieve labor flexibility in that way. So and according to Daniel, he said that labor unions are structured for worker protection and not for efficiency, because two trades cannot go on at the same time in the same area. So that's the reason why they can't achieve more and more productivity. The third issue that we talked about was vertical integration. So according to Vincent, it is very important to educate the architects, contractors, and the clients that are involved in modular construction, because normally the projects that are done in New York are basically design but build. And so when it comes to design but build, most of the work is fragmented between the clients, the designer, and the contractors, and they are introduced at different time frames when it comes to the project. So it is important, so that the team, when it comes to modular projects, it's important to assemble the team at the same time, which is at the beginning of the project, so that it is, everyone is on the same page. And it is important that they get a contractor's perspective when they're designing the building, and they get a designer's perspective in terms of what needs to be constructed. So it is very important to get everyone at the same time, and so that they can do the work more properly. So these photos are of the factory of full stack modular. The one on the left side is the assembly line, and the, the these there are various workstations when it comes to the assembly line. As we move forward in the assembly line, there are different workstations where the module is taken and it's constructed further. And the picture on the right shows the inventory. So for every workstation, the inventory is tagged on the right hand side. So the assembly line focuses on lean methodology when it comes to process innovation. So the flow of labor would be towards the end of the assembly line, and the flow of information would be from the end to the beginning of the assembly line. So when it comes to flow of information, there would be a flow of information that the end the end of the assembly line is empty and they need more modules to work on, which increases the productivity as we move forward in the process. So full stack modular also implements BIM modeling to its most extent when it comes to modular construction, so that the production can be faster and faster. When it comes to the inventory, they prefer putting in blanket orders, which are placing an order with a particular vendor for different delivery dates at a particular price, which is negotiated before the production starts. So that can be very advantageous in cost and schedule point of view both, which helps them achieve JIT, just in time delivery, and which helps them reduce their inventory holding cost. Also, they have achieved what they call payment flexibility with their vendors, so that which helps them, assign their cash flows properly in that particular project. So these are a few photos of the modules that were being constructed at that time. The photo on the top left corner is of 60-foot length, 14-foot wide, and 14-foot high. And when it comes to transporting this module off the work site, what they have done is that they transport it at night from 12 to 6 a.m. so that they don't face a lot of traffic, which helps them in optimizing their logistics part of the challenge. So this particular module on the top left side took them 15 days on an average to build one module, and on the bottom right side it's a bathroom module, which is relatively smaller, and it almost takes 2 to 3 days per module, which is really efficient when it comes to construction. When it comes to modular construction. Now, Smith will talk about the second manufacturing company that we interviewed, which is Kendall.
So our research group was supposed to visit Chicago in March, and we were supposed to meet the CEO of the company, Mark Skender, and visit their offices and manufacturing units. But then coronavirus happened and we were not able to travel to Chicago and meet with him, but he was happy to have a phone conversation with all three of us. So Mark Skender is the CEO of the company called Skender Construction. He joined Skender Construction in 1989. He graduated from University of Wisconsin-Madison with a bachelor's degree in civil engineering, and he was one of the key figures to introduce lean construction management in the city of Chicago. Talking about Skender Construction is basically a general contractor. They are into interiors, multifamily housing, affordable housing, retail, and commercial real estate construction. So they recently started their manufacturing unit. They came up with the decision to start a new department, a new wing of Skender Construction called Modular Construction Department. They cut the ribbon for that manufacturing unit 9 months ago, and they've recruited their own team of designers, and they plan to carry out modular construction with their own team of architects, engineers, and industrial people from industrial engineering field. Um, like further down the line, they also plan to form strategic partnerships with big general contractors who are capable and who understand modular construction. They're happy to act as manufacturer going forward, but right now they're focused on designing, manufacturing, and construction of buildings using modular construction. Moving forward, now Sheila will speak more about Jim Garrison, and over to you, Sheila.
Yes, thank you. So another conversation that we had was with Jim Garrison of Garrison Architect, and his company has focused on modular construction since the company was founded in 1991. And their portfolio includes institutional, commercial, and residential projects. Next slide, please. So part of the conversation that we had with him was about automation and efficiency in modular factories. And he mentioned that the use of robots can increase investments, can increase productivity by 33%, and that investment can pay off in 1 year. So he mentioned a company called Z Modular, and they were able to implement robotics to do certain processes, and that paid off really, really well for them. And another thing that we talked about was how efficient design of the modules will increase cost effectiveness of the project. So if you can see on the bottom of the slide is how Z Modular's vector block system is more efficient, and it actually allows greater flexibility in design. And another thing that we talked about is just general factory efficiency. And he mentioned a project done by Skanska, and one of the managers of the modular factory, he brought in industrial engineers that were well versed in the Toyota Kaizen method, and just implementing those processes, they were able to double the production of their factory. Next slide, please. And we also talked a little bit about the business side. We talked about just different business models, and he mentioned that he thinks that the integrated business model will succeed. So that means having the designer, the construction contractor, and the manufacturer kind of all in one to do a modular construction business, and that business model has the greatest chance of success just because all sides are working together, as Bhumit mentioned previously. Another thing is having experienced designers, engineers, and construction managers will increase the cost effectiveness of the project. He mentioned a project in which the developer wanted a modular construction project, and the engineers and some of the people that were on the project, this was their first time doing a modular construction project. So this being the first time, they had a few cost overruns, but just kind of keep going, and eventually through experience, that cost will eventually go down. And another thing that we talked about was about legacy planning and how that's very important, because he mentioned that when he started in 1991, all the modular construction companies that he has worked with are all out of business except for one. And that's because a lot of entrepreneurs that started the company, they were very kind of gung-ho and worked hard to build the company, but there was no succession plan. And after the founder left, the company kind of fell into disarray. And there's different ways of legacy planning, just training your people to kind of take it over, or kind of getting your company set up to be sold to a different company or a larger organization. Next slide. And so Smith will talk about the legal side of modular construction.
So we had an opportunity to talk to one of our professors at Columbia who teaches construction industry law. His name is Bob Rubin. He has been in this industry for over 40 years now, and he's a practicing lawyer specializing in construction law. He has his own firm. So we talked to him about the legal barriers when it comes to modular construction, and some of the barriers that we discussed are next slide, please. The first is the ambiguity in the role of a contractor. So this ambiguity is basically dependent on the contract, the initial contract drafted before the construction project starts. There's this confusion whether the party to the contract is a contractor or a manufacturer just supplying goods. So this ambiguity kind of leads to disputes when modular construction is used, and it's very important to have contracts which clears this ambiguity and assigns a clear role to a contractor or a manufacturer. Uh, Typically, when the projects have disputes or they end up in courts, the courts have applied the predominant factor test to determine which law applies. So, in short, if the provision of goods is the predominant factor under the contract, the party to the contract is considered as a manufacturer and not a contractor. If, however, the provision of services is the predominant factor under the contract, uh, the party to the contract is considered a contractor. Also, like, different states have different permitting process, different laws when it comes to modular construction. Some states have their own agencies looking after factory built houses, like we saw previously in this presentation with San Francisco. Some states do not have this agency and they don't have much experience when it comes to modular construction. So as someone who has invested in a factory, or as someone who is a manufacturer, uh, when it comes to building modules, it's very important to understand the law and the codes in each and every state. Also, there are different trade licensing agreements when it comes to modular construction. So these trade licensing agreements and labor agreements can also be the source of dispute on a modular construction project. In particular, like, certain construction trades or labor groups with a rightful claim to certain scopes of work at one location may not be applied or recognized at the opposite site of manufacturer or installation. So it all comes down to the drafting of contracts and clearing this ambiguity. Moving on, the second contractual challenge or the legal challenge that is seen when it comes to modular construction is the transportation and who bears the risk. So if a modular builder is considered a merchant or a manufacturer, the risk of loss passes to the buyer upon receipt. Conversely, if the modular builder is not considered a merchant, the risk of loss or the damage that can happen while transporting these modules, it passes to the buyer on tender of delivery. Other important transportation considerations include time and cost associated with customs and international shipping, truck weight and height limitations, storage, and insurance. Um, the third contractual challenge is the delivery. So delivery in modular construction does not conform to the same requirements of standard construction contracts by requiring a certificate of occupancy or certificate of final completion. For that reason, modular construction contracts must establish a protocol for when and how delivery of modules to the project site must specify survey and inspection procedures, as well as any testing, final sign off, or acceptance procedures. These issues basically, like, boil down to the single most important thing, which is the role of an entity, whether it is a contractor or a manufacturer. That is, I feel, uh, that is the root cause of the disputes that generally happen when it comes to modular construction. So moving on, Bhumit will speak about our future research options and opportunities that that we can delve deep into.
Thank you, Smith. So we really enjoyed doing the research on affordable housing and focusing on modular construction further. And it was a very good learning experience for us. So if we were to take this research forward, we would like to look into these three specific things. The first one is the implementation of automation and robotics when it comes to the supply chain, when it comes to the assembly line of the modular construction unit. So we would like to look into where we can apply automation or apply robotics and what part of manufacturing it can be applied into. The second thing we can look into is studying similar manufacturing approaches to implementation in modular construction. So when it comes to manufacturing, shipbuilding and aircraft building is also done with a similar approach where there's a moving line assembly and the whole product is moved in the assembly line where different processes are done on that. And when it comes to modular construction, it is the assembly line is very similar to these aircraft manufacturers and shipbuilders which that they use. And the third thing we would like to focus on are flexible factories. So when it comes to the automobile industries to manufacture different kind of automobiles like sedan or an SUV, they use flexible factories where at a certain point in process they can implement different things so that they can manufacture different products using the same assembly line. This can also be implemented in modular construction where there are different modules in the same project, and these kind of modules can be made in a single assembly line. This concept can be useful moving forward, and we would like to research on these topics. So to thank, so we had a very really good project, really good year when it comes to this project, and we would like to thank our Professor Finyoski Pinamura. We would like to thank Professor Rick Bell and Professor Charles Shin for helping us throughout this project. And we would also like to thank all the industry partners who had a conversation with us, which are Full Stack Modular, um, um, Full Stack Modular, then there was Garrison Architects, there was Professor Bob Rubin who gave us valuable insights, and there was Kender Construction who gave their valuable insights as well. Thank you.